All right, we're officially recording, and everyone should be seeing my screen. Are you seeing, should be a Google presentation right now? Perfect, cool. All right, so cool. So thank you everyone for coming, and welcome to our first meetup for Data 608, Knowledge and Visual Analytics. Let me move this around. Cool. So just to start out with introducing myself, I currently, on this slide, you'll just see sort of a couple of companies I've worked for, organizations I've worked with, some tools, projects I've worked on. Currently, I work at Plotly. It's a data visualization startup based in Montreal, and one of the tools that we'll be using for this course. Has anyone come across Plotly in their studies yet? Cool. I'm always excited to see that people coming into this have been using the tool for other classes. So that's always good to hear. Cool, awesome. Betsy mentioned that it was used for a project in 602. That's pretty much how like 602 is the Python course, and that's pretty much how I, put the focus on Plotly, mainly using it for Python, because with R, you sort of have a more established visualization ecosystem with ggplot. Python is a bit more fragmented, so tools like Plotly, Bokeh, Matplotlib, all of those different, there are a lot of different libraries that you could use there. So I found definitely comes up more in the Python context. So yeah, just in terms of everything else on here, I had previous experience working with a company called Global Insight, which is an economic forecasting company that sort of really ignited my interest in sort of first discovering kind of the modern data science ecosystem, actually through a couple of proprietary tools that I used to work with in Global Insight. So sort of seeing what economists like more classical tools that economists use, eViews, if anyone has come across that, although it's pretty specialist for econometrics. So unless you're specifically doing time series forecasting, it doesn't come up that much. But that sort of is what originally um, led me to my interest in sort of data science. And then as well, I listed Beta NYC, which is sort of a group that does a lot of civic hacking with open data in New York. I actually use this a lot for a few of our projects. So, I will be sort of leveraging, open data sources. And, one of the, like, I think this is sort of a very positive development to sort of come out of, civic engagement, being able to sort of have access to these open data sources and, being able to use that to, drive more civic insights. So just to quickly summarize what this class is about. Obviously this is a data visualization class, and I really see data visualization as about communication. So we'll be mainly we'll be sort of talking about kind of how to sort of building on what you've learned in former classes, and sort of thinking about how to present information. So, on one level, you could think of data visualization as just simply decisions of what sorts of data visualization techniques to use, and we'll absolutely be talking about that a lot in both the discussions and in a lot of the assignments. Quite a few of the assignments will be geared towards sort of students' choices in visualizations and different techniques. But I also like to bring in, sort of data visualization as almost kind of the last stage in any sort of analytics pipeline. So when you do come across kind of data visualization in more professional settings, it's really sort of geared towards use cases like that, where you may be a data scientist, you may be sort of working in there in sort of your own tools in an ad hoc style. And I see a facet of data visualization being, how do you then take what you're doing as a data scientist and present that to other users, to sort of a wide variety of users. And in that way, one of the themes that I'll touch on a lot during this class is, in practical terms, that almost turns the study of data visualization into kind of the nexus between data science and web development. A lot of and looking through the syllabus and the modules, you'll see quite a few of the, especially with the later assignments, we use sort of starting out with tools that are a bit more geared towards a data science use case and building interactive apps. I try to early on highlight the idea that even though it seems like we're working with data visualization platforms, really we're sort of at the borderline of web development, and then of course we'll be talking about more kind of strictly web development tools like Flask and JavaScript, and how you could sort of use tools like that in data visualization. So really, I see that as the nexus of where this class lives in practical terms. And by the way, if anyone has any questions, feel free to just put it in the chat and I'll address them as people ask them. But definitely don't be afraid to kind of keep the discussion going there. So I went through a lot of this in the announcements and in what I've posted in Blackboard so far. The class dates are all in, the class dates are in either the syllabus or in the content sections. So when when you go into content, you'll see all of the modules. Those modules mostly correspond to modules within the GitHub repo that is posted right here. And that there's the last assignment is going to be more geared towards your final project. So it's so there's not a separate module for that, since that's going to be different for each student. And but most of the time you'll see sort of separate modules within the repo. Every other week, a homework will be due. So the first assignment is due this Sunday, and then sort of every 2 weeks, homeworks will be due. Every week, I post a new discussion forum, a new discussion. I post a new forum, and there will be a new sort of topic to discuss. For the discussions, that's really where class participation is being measured. So definitely, I try to get all of the sort of first posts in by Thursday. So for everyone here in section 1, make sure you spend either the time after the class or tomorrow getting at least those first posts in, and then we can sort of spend the rest of the week being able to comment on each other's posts and sort of keep the discussion going in that way. The homeworks are more practically oriented, so I will sort of I'm sort of treating this as more of a survey of different data visualization tools. So we're starting out with the first assignment is R, and then we'll be sort of moving back and forth between R and Python, depending on sort of different tool sets within them, and then sort of finishing off the course with JavaScript. And all of that will be in the syllabus. And then at the end of the semester, there is a larger final project that will be worth, I think I changed the percentage slightly, but should be either 40 or 50%. And but either way, it's a large portion of your grades. So definitely, definitely, keep track of the final project there. Heather mentioned, asked a question about the quizzes mentioned in the syllabus. I actually had meant to remove that from the syllabus, so I'll post an updated version of that. The quizzes were something that I had tried out, but I didn't really sort of think it was best for this particular course. So I'm sticking mainly with the discussion posts, sort of using that to be the more discussion-based aspect of the course, and then sort of having the homeworks be kind of the more practically oriented project-based section of the class. So there will be no quizzes. Cool. And then so I had mentioned there is a course GitHub, and one of the easiest ways to kind of work with the course is to just fork the repo and kind of work within that and post your sort of keep your homeworks within your GitHub repo. It's so in the introductions, I had asked everyone to sort of list their GitHub accounts. Submissions are definitely preferred. GitHub link submissions are preferred. So that makes it just easier to be able to sort of receive everyone's work, and also is just good practice to get into. As you guys are moving on professionally, you will be using GitHub a lot if you're using these tools. So it's definitely sort of a good to sort of get used to using GitHub. So with that, we'll just get started with some, in this sort of introductory meetup, we'll just sort of go through some visualization technique and theory. So this picture, does anyone have an idea of what this is a picture of? And why it might be important for data visualization? Yep. Yep. So Betsy mentioned Betsy mentioned the Challenger explosion. That's indeed indeed what this is a picture of. That happened in '86, and it was a pretty big tragedy. It was there were astronauts on board, and it was a just complete disaster. And what had actually happened was it's something called the O-ring, which is on sort of individual rocket fuselages. So you could kind of see these little white arrows that are pointing to where you could see, sort of a fuel leak happening. If you see it in the three pictures, it's so these O-rings are sort of what's adding to the structural integrity of the fuselages, and one of the O-rings sprung a leak, and it's sort of dangerously close to the actual fire of the rocket. So that's pretty much what caused the disaster. And this was something that this is actually an example that's highlighted by an author named Edward Tufte. Is anyone familiar with Tufte? He's actually someone who will be drawing on a lot for the discussion posts. Oh, awesome. Betsy mentioned that he does have a one-day course, and yeah, it's he has a series of data visualization books. A lot of the yeah, exactly. Jeremy mentioned that his books are really cool, make cool coffee table books, and oh yeah, Betsy mentioned you get books as part of the swag for the course. That's really cool. And this is one of the sort of um, examples that he gives about really, why data visualization matters. So this is actually what the visualization that the engineers were using, when they're sort of making recommendations for these. Uh, yep, and Gracie mentioned if I could make this full screen. I'll try to go back and forth because I do want to kind of keep track of the chat. So um, so I'll try to go back and forth. But just to present here, cool. Oh, and actually, oh, neat. It's okay, awesome. So I'm going to stay in full screen here because it looks like the chat is showing up. So this is the actual visualization that the engineers were using to make their recommendations. So there's, you're able to kind of see a lot of test launches, and you could see there's, sort of markings of when there were failures. So you could see the yeah, it's not labeled, but I believe there's like two O-rings. So if there's sort of a more like with the lines, that's sort of a single O-ring failure. I think with number 15, there's a double O-ring failure, and yeah, there's I think there's something going on there that's not specifically labeled, but really the take home of this is you have these like where the O-ring failures are happening, and with each trial you also have the temperature of the launch date of sort of the trial date. Now, looking at this specific visualization, does anyone can anyone see sort of the pattern, or can anyone sort of make a conclusion about how temperature might be affecting the O-ring behavior? Yep. So Baron mentioned it. Yeah, definitely takes effort to do so. June mentioned the higher temperatures have more of a chance of a leak. Um, it's actually the opposite. And it's sort of the point of all this isn't the best visualization. So all of the information is here. This is giving you sort of where there are where the O-ring failures are happening, what the temperatures are, but there's no real visual pattern to really guide a viewer to see like what might be happening. And Tufte uses this as an example to sort of show like how this could be compared to a successful visualization. So this is what Tufte recommends gets used. So you could see he has a measure. He sort of plots this out on a scatter plot, because what I had asked before was, what's the relationship between temperature and O-ring failure? And a lot of times when you're asking questions about sort of that relationship, a scatter plot is always a really good jumping off point to sort of get information about that. And here you just immediately have a better sense of what's happening, of what's sort of what the pattern is. First of all, it's a smaller number of trials. It's something where if you were to try to sort of use a statistical test, you may not really get anything significant. And partially, it seems like it could be a data collection problem. Like this is all based out of Cape Canaveral, so it's Florida weather. So there's you're not really likely to get cold weather that much. But but you are still able to see a visual pattern. So you could see that basically the pattern is as temperatures are getting colder, you have more O-ring failures. So you could see that you kind of really have this kind of jumping off point when you get below 65 degrees, where you have no successful no fully successful trial launches, and you start having you have one O-ring failure at 75 degrees, one at 70. You sort of have a really bad run at around 50 to 55. And for the launch of the Challenger, it was just unseasonably or just climatically not usually what you would see in Florida. So there was just very very abnormally cold weather, and so looking at a graph like this, one could sort of get more of an idea of what the pattern is. And there's in the chapter where Tufte talks about this, he actually goes, he sort of goes through kind of the story of what was happening, and it turns out there was sort of a very, there were a few adamant engineers who were against the launch, who sort of knew about this relationship, but they were sort of going off of this visualization. So if you're, and I don't know exactly what the decision-making process is there, but if it's perhaps engineers versus non-engineers, and the non-engineers who don't study this every day are going off of a visualization like this, it's harder to really drive home the case. Whereas if you see a visualization like this, it drives that home a bit more. And we'll go through a few of the sort of the concepts that this uses in the discussion boards for our first week's or technically week 2 discussion. We sort of are touching on one of them, which is the data to ink ratio. There's a few more major ones that I'll touch on today, and then the rest we'll go through in the discussion boards. And then to sort of bring the point home, we have a few other bad visualizations here. So if we could use the bar chart as a quick example, if anyone sort of knows or could see what might be happening there. So why is this bar chart a bit misleading? Not a bit misleading, it's majorly misleading. Not just the sequence. So yeah, Jeremy mentioned it's the sequence of years. Yep, and yeah, Jeremy, you're right, and it's the scale. And Heather, you have that with the non-zero start. So basically, what we have here is we have temperature. We have sort of warming over a period of years. The technically the dates are okay. With bar charts, a lot of times the focus, especially I would say with a smaller number of bars, the focus is on kind of something more categorical rather than like if it were a large number of bars like that usually, and you're looking over time, that would suggest you're looking at a time series, something that is sort of comparable to a line chart. But but a lot of times, bar charts could be interpreted as categorical and not entirely linear. And then another student, who was it? Betsy mentioned the bar chart, the pie chart. The percentages aren't adding up to 100, so it's very unclear where the data is coming from there. And then for the last two, these are just kinds, some like in the circular bar chart, it's not really, it's not really sort of clear what we're what we're looking at. Like we're sort of, it sort of suggests that we're looking um, at sort of, time of day, but it's, you sort of have midnight and noon, um, top to bottom. So it's, sort of a bit unintuitive there. And then for the line plot, it's that's just simply too noisy to really draw any conclusions from. So, looking at something like that, there's really just a jumble. Sort of a viewer isn't really able to see what might be happening there. Yeah, Jeremy mentioned with the pie chart, do they all win with the majority? It looks like it. So just to sort of try to get a summary of what are the goals of data visualization, you could sort of frame it as you want to minimize mental effort, make information easier to retain, and really go for insight over beauty. And we'll be touching on a lot of these as we go through the, sort of a lot of our Tufte concepts in the discussions, but you could really see these as the kind of major driving goals of data visualization. And this is actually going through the first, the first three, and what I would argue are sort of really the most important visualization strategies, which Tufte introduces, which is matching the display to data and purpose, maximizing the information to ink ratio, and using what's called the principle of small multiples, which we'll get into later on here. So we'll start with matching display to data and purpose. And there's a few slides that should be posted in the GitHub repo coming from Tamara Munzner. She's she sort of studies data visualization from almost a sort of neurological and cognitive bent. So she's really a leader in the study of kind of why sort of neurologically why certain data visualizations work better than others, and really she sort of maps all of this onto different types of data. So here you could here this is a diagram of just different data types that you may come across. So the three major types being relational, spatial, and tabular. So first, just to define what these data types are, relational and spatial, these are sort of the, like most of the data you run into is going to be tabular. Relational and spatial are a bit more, not obscure, but less often ran into. So relational data is really about links between points, so it's networks, and you could see a lot of examples here, things like family trees, international trade. So if you're looking at like bilateral trade information, really the what you're looking at is you have a source country, you have a destination country, and you're looking at sort of statistics of what's happening with the trade there. You could technically put that into a tabular format, but really the form of the data is more relational. And the diagram that we have here, this is actually relational because we're sort of looking at hierarchical, tree-like structure. Yep, and Jeremy mentioned graph structures. That's exactly it. And then there's spatial data, which we won't touch on too much in the class directly, but just to kind of show like what sort of data we're dealing with here. Like spatial data is really where you have an intrinsic position. So maps are really the that's really what we're talking about when we talk about spatial data. But you could also think of things like, and maps could kind of refer to, more than just kind of, what we normally think of as geographic maps. It could be things like sky maps, looking at the position of stars in the sky. That's something that would also be considered spatial data. And then we have tabular data, which has a lot of different subtypes. So, the two main subtypes being ordered and categorical. I sort of mentioned this before when we were talking about the bar chart, but with categorical data, this categorical data is really like discrete, distinct, and when compared to ordered, there's not really an order to it. So the example being given here, you could sort of think of different types of fruit: apples, oranges, grapes. That's categorical data. There's no, aside from something like alphabetical, there's no real order to the categorical data. It's just simply discrete categories. You also run into discrete categories, discreteness when you are in sort of the ordered realm of data. So something like shirt sizes, small, medium, large, or extra large. Bond ratings, AAA, AA, things like that. Those are situations where the order matters, but it's still discrete. There's you're still dealing with categories, so it's kind of like a hybrid almost. And lastly, probably the most familiar for sort of most often ran into type of data is continuous, where you're dealing with some sort of number. You're dealing with some sort of measure, and there's sort of a continuous sort of that measure is continuous. So if you're dealing with weight, you have 5 kilos, 2 ounces. If you're dealing with time, that's a continuous scale that could be broken up into various subsegments. Most of the time, if you're sort of dealing with temperatures or any other sort of numeric measure, odds are it's going to be a continuous measure. So then, once we sort of go through what the different data types are, we could then begin talking about like what is the best way to display each type of data. So spatial is the easiest. I mentioned we're usually talking about maps, and maps are indeed the way to display that style of data. So there's not really much to go into there. And then this might look a bit confusing. It's not totally tied to different chart types. But what this really goes into is Tamara Munzner is really sort of mapping this into how sort of humans essentially process what they're looking at. So if you're looking at a bar chart, for example, a bar chart is, and we'll get into this when we actually get into here, like ordered data. With a bar chart, you're technically looking at length. So you're like what you're seeing when you see one bar is twice as high as another bar. It's the length of those bars that matter in terms of representing information. So for relational data, and I sort of showed that off because with ordered and categorical, you're a bit more tied to kind of classical, more often seen graph types. But with relational data, so with contain, does anyone have a guess as to what sort of visualization type? I don't even want to say graph, but like just sort of method of visualization contain might be an example of using using contain. It's a bit tricky, and it's totally yep, yeah. And actually, Jeremy, you're getting pretty close when it comes with grouping, similarity, KNN. So you could. I'm actually trying to think if you would be able to like I guess a Voronoi diagram would would sort of be using this contain method. So you could sort of see that as KNN. But even sort of simpler than just looking at a sort of machine learning algorithm, you could think of something like a Venn diagram where you're sort of, so Jeremy, this is getting to what you mentioned about grouping and similarity, where you have sort of interlocking circles. You're able to sort of visually see that sort of set notation. And then things like connect, that's sort of a tree, similarity, and proximity. And these are ordered in terms of what's best versus these are best, these are less good. And then for ordered, you have position, so things like scatter plots, length, things like line plots. And I'll get into this a bit later on, but with one sort of interesting neurological finding is that the human brain, when you're looking at length, that's pretty much one-to-one. So if you perceive something as being twice as if you perceive a person as being twice as tall as another person, odds are that's what their height is. But that doesn't really map the same way onto something like area. So if you were to sort of so like if you were to sort of ask the question like how much bigger is this bigger square than this smaller square, you could kind of mentally slide them together and try to get an idea. It's easier if you're you sort of map it onto you think of it as a series of squares or rectangles. You sort of subdivide it. Technically, what you're doing there is essentially reading the length and sort of doing the math based off of that. But there's less of an intuitive sense of this square is twice as big as this square. And later on we'll sort of get into sort of what actually the brain is perceiving there, and then shade, saturation, some other ways of looking at that. And then similarly with categorical data, so looking at things like position. Position could actually refer to a number of strategies, something like small multiples. That could be sort of considered position, where you may have sort of different, and we'll get into what exactly small multiples is, but essentially you're looking at different graphs that you're comparing, and you're looking at the position of them. Things like color, you could think of different colors within a scatter plot. A lot of times, one of the dimensions of a scatter plot will be a categorical variable that you're coloring with, and that's a pretty good way of showing that. Also, if you have a line plot and you have two lines of different colors, that's also using color to define a category. And then shapes and patterns. So to sort of test this out, I kind of briefly just showed the next slide. I'll quickly show it again. So what were the sort of first things that popped into your mind looking at that graph? So I know maybe some of you were able to see what to read some of the labels, but just based off of like what you saw in that split second, how would you describe what you saw? So remember, like, try to relate it to what we were just talking about here. So if it's something like if there's a trend that you noticed, or something like that. No worries. And actually, we'll just go to the graph here. So basically, you could like some of the first highly ranked things that you'll see is you'll see the trends of the line. So if you weren't if you saw this for a split second before you sort of were able to process that we're looking at well, actually, one would probably guess just being a sort of line, sort of line plot like this. Very often, that is sort of denoting time. So, I wouldn't be surprised if a lot of people were to guess something that that this was looking at information over time. I would guess most people would see that there's sort of a trend, sort of an upward trend, and then a downward trend. So there's a peak that is happening at some point in this graph, followed by the valley. And then you could sort of see like the less highly ranked channels. So something like most important, you have the actual housing prices. So that trend is sort of what you're mostly seeing. Second, you would see time. And then third, you would see the categorical distinction of different cities. So here we're just, sort of comparing two cities and seeing how they fared during the housing boom and bust. And to help get us sort of thinking about what we're sort of what we'll be doing in R. This is just some sort of explanation of this graph using the grammar of graphics. So we when we're looking at our data, the main sort of instructions of the visualization is being defined in AES, and you could sort of see we have our X, Y, and color that's being mapped, and then sort of displaying how we're going to display that. And I think that should have been geom line, so I just mistyped that. And to bring this back to Tufte, so we were looking at some line plots, and this is sort of the next major strategy, visualization strategy, which is maximizing the information to ink ratio. So really, you could think of this as minimal, like minimalism in your data visualizations. If you are able to remove elements, you remove elements that don't detract from what a viewer is actually receiving from the visualization. It's usually a good idea to sort of try to remove those, as if it's not really showing any value, all it's really showing is just distraction. So taken to its logical endpoint, you end up with what are called spark lines, where you could see very minimal axis labeling. A lot of times you won't even see axes defined. A lot of times, like really, the only point you want to drive home is the trend and perhaps a start and end date. It's not really meant for a user to know what exactly was the stock price on October 8th, but really what the point that you're trying to drive home as a person creating these data visualizations is this is the trend. There was flat stock prices for a while, and then it sort of lifted up in the middle of the time period that we're looking at. And then this sort of flows into the last kind of major data visualization strategy, which is the principle of small multiples. So here you could see, sort of a strategy of looking at different items. So in this case, we're still looking at stock data, but we're looking at it in a more comparative way. So we're sort of trying to, over the same time period, see what the behavior of different stocks are. And you can plot these over each other, but one problem you could see right off the bat is we have different price levels. BlackBerry, for example, you see prices at around sort of single digits. Apple is in 400s to 500s, and if you were to plot all of these together, you just naively plot all of these together, you would end up with kind of a flat line near the bottom of your axis. And actually, they would probably all be flat lines, because we're, except for the higher numbers. And it wouldn't be as informative as looking at things comparatively this way. And again, this is just some ggplot sort of pseudocode to see what we're working with here. Facet wrap and facet grid are the two functions in ggplot that really show off how to facet like this and use small multiples. And then this is actually pulling from a Harvard Business Review author who Scott Baronato, and he had sort of another take on small multiples as making sure that your measures are comparable. So sort of the comparison of having dual y-axes versus looking at a price change. With the price change, you're getting more, you're sort of getting a clear idea of what's happening. From the first graph, it's not clear, for example, that silver prices are, at least on a percentage basis, more volatile than gold prices. You see there's sort of a higher peak in sort of early 2014, and then lower levels as you get to end of 2014 and 2015. And then in practice, you could sort of see a few examples here. I'm going to start speeding up a bit because we're running a bit out of time. So apologies if I go a bit quicker through these slides. And this is continuing with Scott Baronato. He's actually, he spoke at one of our Plotly events, and he's sort of a more modern take on a lot of these visualization strategies. And comparing him to Tufte, I found that he reframes a lot of these strategies. So, he doesn't use Tufte terms like data-ink ratio, but what he tries to frame visualization strategies as it's informed by the point that you're trying to get across. So so it's almost a conceptual version of maximizing the information to ink ratio. So the way he explains this is you could think of and this is a way of saying sort of a picture's worth 1,000 words. You have some text like this, and apologies for going through too quickly, but basically the point being, this is giving quantitative information, but it's not, entirely clear, really what this is showing. You have to read through it. You have to sort of think about what you just read. Whereas this information could really easily be shown using, and this is even getting, this is sort of an even more pared down version of sparklines. So for something like this, we're not even concerned about the trends. We're just concerned about sort of a one period change. We're concerned about a start time and end time, and what's the change during that period. So, you could see a lot of text is replaced by, here you could think of this as kind of a conceptual version of data-ink ratio, where, we really have a pared down visualization, and we're sort of thinking about this in the, more conceptual realm. And the thing about thinking about it in sort of a more conceptual realm is, I sort of like to think of this as, you can really begin, thinking about the data-to-ink ratio in a different way, and new problems end up coming up. So in this case, I'm presenting a graph here that's showing vinyl sales since 1993. And, you could see that hipsters really seem to be driving up vinyl sales. You could really see the pattern. It's, really there's something, there's something unprecedented happening. And I'll skip through the next couple of slides. I had sort of a Trumpian whoops. So I'll skip through. I'll skip through some of these. So looking at this visualization strategies reframed section here, can anyone sort of think about what might be missing from a visualization like this. So I'm making the claim using this, like you could see, there's nothing screwy happening with the, scales. It's not like this is, sort of misleading bar chart. Definitely it's anchored at zero. So, we are seeing vinyl sales, pretty much quintuple since the late 90s. So that does seem to be a very substantial change, but there's something else that might be missing here that might make a visualization like this misleading. So can anyone think of sort of think outside the box a bit and think about what might be misleading about a chart like this? Betsy, yep, you got it. So Betsy asked the question, what were sales before 1993? So looking at that, you can see that, sales in the 70s when vinyl really was in its heyday, when vinyl really was in its heyday, you could see that, that sales were extremely large. Other things that we might possibly want to look at would be sort of comparisons with different types um, of of ways to sell music. So comparing this with MP3, iTunes sales, comparing it with cassettes and 8 tracks if you're looking at different types of more physical mediums. Betsy mentioned she has a very large record collection. Um, but yep, and Sang Yoon mentioned population. That's definitely another thing that we may want to look at. There's, if anyone uh, follows XKCD, he has a one of his cartoons is about sort of choropleth maps where you sort of try to look at patterns across geography, and what you're actually just showing is a population map. You're showing where cities are located. So if you're looking at just crime numbers, for example, you're obviously going to have more crime where there's more people. So really, the sorts of things you need to look at is per capita growth. So yeah, Sang Yoon, absolutely, like things like population, things like income levels. If you sort of as you have more disposable income, you're going to be spending more money on vinyl. So there's lots of different things that you may want to look at. And I bring this up because I didn't really have a chance to go through all of this, but really like this I sort of go through this in the context of politics where you're sort of looking at visualizations, and really what matters is the context. So sort of when you are trying to analyze like what is what you are hearing in the news, you sort of it always helps to kind of take a step back in terms of context and see. So this was looking at a Trump speech, sort of saying that the economy was doing better under him than it was under Obama. He technically didn't, lie about any of this. He gave numbers, and the numbers seem to clearly show that the 3 data points he mentioned of his economy were better than the last 2 data points of Obama's economy. But what matters more than that is the context. So, taking a small chunk like this and looking at gross domestic product growth over time, you could see that really we're looking at this small section, and there's no real noticeable pattern. So really with that context, that's kind of a subtle way of sort of almost not totally lying. You kind of need to come up with a new word for that, but just misdirection through data visualization. And then lastly, this is again, from going back to Tamara Munzner's slides. And what this is actually showing is, if you remember before, I was talking about kind of how the human brain interprets various various cues, and this is looking at kind of what the perceived sensation is versus the actual intensity. And with something like length, length is actually the best, one of the kind of best mappings in terms of perceived versus actual intensity. So, when, as I mentioned before, like if you're looking at a bar chart and if you perceive a bar to be twice as tall as another bar, that's pretty much what's happening in reality. Whereas in area, and these are sort of based off of empirical studies, you sort of have different relationships in terms of the actual intensity versus the perceived sensation. So you could sort of see how area is sort of third best compared to other other metrics here, but there's different sort of different power laws that you look at. So hopefully no one will be using electrical currents for their projects, but that doesn't map realistically onto the actual intensity versus perceived. And then lastly, this is just a few points to keep in mind in terms of discrimination, like discrimination between different categories, for example. So this are just general rules of thumb. Pie charts. Usually, I like sort of like to keep that around three around three categories. As you get more, like pie charts are actually focused on showing area. So if sort of comparing that to these dimensions, you could sort of see areas not the best, not really truthfully mapped onto sort of a one-to-one relationship. Jeremy mentioned Tufte says no pie charts. It's I think he also focuses. I forget if he actually says no pie charts. I think he only says that because it's just so easy to go wrong with pie charts, and there's usually a better way. And yeah, Jeremy mentioned there's almost always a better way. I I mean all of these rules they're sort of, there's always exceptions. There's always some room for interpretation. These are really meant to be guidelines. And for something like pie charts, there's I like to think that they're useful for sort of smaller like smaller numbers of categories. Like definitely if you're looking at two categories, it very clearly shows because you're able to see where the halfway point is. It works with three categories if as long as you're not getting too equal with the pie segments. But yeah, like yeah, Jeremy, you're right. I think Tufte does come down pretty hard against pie charts. And then and actually, yeah, for both of these, I think I break the rules in some of the assignments. So take these as guidelines. And then, whoops, sorry, I meant to, yeah, exactly. Jeremy mentioned rules are meant for breaking. So that's it for the content portion. I have just a few of the authors I was talking about. I didn't get into Mike Bostock. Mike Bostock was the creator of D3. He had previously worked for the New York Times, created D3 as he was working there, and really led their kind of data-driven journalism efforts. And then Jacques Bertin, think of him as coming before Tufte, but sort of in the similar vein of the sorts of problems Tufte was looking at. So with that, unless anyone has any questions, and if you do, put it in the chat and I'll address them, and I'll just go straight to homework 1. So so I hope everyone has at least taken a look and sort of played around a bit with module 1. So just in the repo, you'll see a few files here. You have just HTML files that are sort of created from an R Markdown file, but the R Markdown file is where the assignment really is. And I have that opened here. It should knit for you guys without an issue. It's just reading data from the web, so you don't need to sort of worry about having your data local. And you could see sort of a few previews of the data, and I pretty much provided the template to answer the questions. So for assignment 1, all you guys need to really do is fill out the templates with visualizations that answer these questions. And so any questions based off of what you've seen in the homework so far? And I'll actually just bring in the data so we could take a look at what it looks like. So yeah, the sort of data that we're looking at, we have sort of the Fortune 500. So we have a list of companies, and we have just some various stats about the companies. So things like revenue, growth rates, number of employees, and location. So here, pretty clearly tabular data. And in terms of there it is. And then in terms of the questions for especially for the first 2 assignments, the focus will be a bit more on kind of visualization choices. So, the questions are a bit open-ended. They're sort of open-ended by design, and it's, really meant to, kind of let you guys make choices in terms of the visualization. And Jeremy, you mentioned Jeremy asked a question about capturing the full distribution. Whether we should use or avoid scaling. In what way are you thinking of using scaling? So I'll leave the choice up to you guys. There are ways of using scaling to deal with outliers. There are some other methods. Really, I'm leaving that open for exactly. It's going to be your choice. But you're not. There are ways of using scaling to deal with outliers. I don't want to obviously give away too much of what could be done there, but yeah, Jeremy, you're not totally in the wrong direction there. Any other questions? Cool. So I have my second section starting in about 5 minutes. So thank you everyone for attending. And I look forward to yeah, Jeremy. Jeremy asked if I could share slides. I'll post the slides in the GitHub repo. And yeah, thank you everyone for coming, and look forward to a great semester. So for those of you from section 1, we do have a cap. We're not really approaching that cap now, but the reason why we have 2 sections is because you can't have everyone in one. So yeah, if you guys could sort of close out of this, I'll just keep this on for the next session, and I'll see everyone in about 2 weeks. Cool. Hi, Gabby. anyone else from section 2? I did. Cool. Hi, Eleanor. Nope. Eleanor asked about the start time. The start time for the second section is going to be 7:45. Cool. So glad to see everyone here. I'll let more people filter in. I'm just going to step away from the computer for a minute, but we'll be waiting for more people to come in before we start. So let me get back to the first slide. And I'll pause this for now. Yes. Eleanor just asked a question if you want to join the section 1 session. I'm totally open to people who want to switch sections. I don't think things are going to get too far out of balance. Like both sections are fairly evenly weighted, I believe, and I don't think we'll run into issues there. So. And I'll make an announcement in section 1 as well if anyone wants. Sometimes people want the later sections if it conflicts with work. Cool. So I'll just give everyone greedy or masochistic, Gabby. I don't agree. Gabby asked if you want to be greedy and hear it twice. You can see if I get better with practice. Eleanor asked what the start time for section 1 is, and that's 6:30. For everyone coming in, thank you for coming to our first meetup. And I'll give everyone about about like 4 minutes to come in, and then we'll get started. Once again, for everyone coming in, we'll be beginning the first meetup in about a minute or two. I'm just waiting for everyone to come in. Before we get started, any more questions? Had a few questions from some people who came in early. Did anyone who came in the past minute or two have any questions before we get started? Cool, thanks, Gabby. Yeah, that's what happens when you're based in New York. Gabby apparently heard the siren out there. All right, so I'll get started here. We're recording this, so I'll be posting recordings in the same meetup info session. So let me. Is everyone seeing my screen and seeing my mouse move? Cool, perfect. Let me get this here. All right, so welcome everyone to the first meetup of Data 608, Knowledge and Visual Analytics. And I'll just start out by introducing myself. So I'm Charlie, Charlie Ferrari, and I just have a few sort of places I work, technologies I work with, just on this slide here. I currently work at Plotly as a application engineer there. Has anyone come across Plotly in their previous courses at CUNY here? Cool. We have a few people that have. Plotly is a really cool cross-platform data visualization tool. Yeah, sure. Someone from the earlier section mentioned that it's being used in 602. I find it's more useful there versus places like R, where R you have a very well developed ggplot ecosystem, and with Python it's a bit more fragmented. You have a lot of different visualization choices there. But yeah, we'll be using that. It is cross-platform, so we'll be using that in a few different ways. Yeah, Nick mentioned ggplotly. We have sort of translations between matplotlib and ggplot in R. And then I just have a few other sorts of former places where I've worked. I used to work at Global Insight, which is an economic forecasting company, and that really was what kind of kicked off my interest in data science. Like, this was really before the data science ecosystem was what it was today, and in a lot of ways, I was working really closely with economists, helping support tools that they use. So if anyone has an economics background, you may have come across a tool called eViews. And in a lot of ways, I sort of like thinking of things like econometrics, a few other fields, as almost data science before there was a word for data science. You're doing a lot of the using a lot of kind of similar techniques, and but these fields have existed for a while. It's only really recently that we sort of have come to look at all of this under the umbrella of data science. And then lastly, the organization Beta NYC. I've worked with them. They're a meetup group that focuses on civic hacking, and that's just a sort of area that really interests me personally, and I'll use it for some of the projects that you'll be assigned over the semester. And it's I just find it's a pretty cool way of seeing these data science tools being used in action. A lot of government data is really being put out there, and practitioners are running with it and really coming up with sort of unique views of data. This picture here, it's a screenshot of a project I was working on where I was comparing sort of green taxi cab data. Like, this is looking at Forest Hills in New York, and I wanted to kind of visualize different like cab share avenues. So, sort of looking at something like this, we're looking at all cabs going to this express station. And, I had known of this route. This is 108th Street in Queens, where you pretty much stand by a bus station and you're able to pay $2 to get to the closest express station. And this was actually a nifty way of not only seeing what what I had known, but looking at being able to sort of find out where else this was happening in the city. So that is really like this with this open data out there, really any sort of question that you have like that, you would be able to find an answer to. So that's an introduction for me, and then just a quick introduction for the course. Really, this is looking at the essentially communication side of data science. That's sort of the broad conceptual way I would describe what we talk about here. And there's a few themes that we'll go through. So at its core, data visualization, you could sort of think of it as different kind of data visualization choices, and what works best for different methods. You could boil that down to what choice of graph or what choice of particular visualization one should be using. We'll be addressing some questions like that, but really you could look at these sorts of questions a bit more broadly. And I sort of think the broadest way of looking at it is helpful, sort of thinking of it in terms of communication. And then one other theme I'll be sort of working into the course, because this is structured as kind of a survey of different data visualization technologies, and from a practical perspective, a lot of the way that you could view data visualization is really as part of a data science pipeline, and you could see it as kind of the last stage of a data science pipeline. So you're a data scientist, you may be sort of working in an ad hoc way in various tools with whatever data you're working with, and the sorts of questions that we think about in terms of data visualization is essentially, how do you communicate that work? How do you sort of, move it from what an analyst or data scientist is doing to, we're actually going to make business decisions out of this. We're actually going to begin showing this to decision makers and sort of enable them to use the information to make decisions. So sort of thinking of it in a business process style like that. And then lastly, just from kind of a technological standpoint, I like to think of data visualization as really the junction between data science and web development. A lot of the earlier on we'll be sort of focusing like more in RStudio with Python and Jupyter Notebook, and we'll be working with sort of those more data science friendly tools, and then we'll sort of move into more interactive visualizations. And while we'll start out in environments like Shiny for R or Dash for Python, it's even from the very beginning, even from using Shiny and Dash, really what you're doing is a form of web development. You're sort of it's abstracted away, but you're really that's what's being done, and that'll become even more clear as we move on to more advanced Python tools like Flask, and then moving into JavaScript, which is the base language of the web. And then just in terms of the structure of the class, general class info, the dates should be updated in the syllabus, so you can see all class dates there. They're also available in Blackboard. So if you go to the content section, you'll see all of the different links, due dates there. Every other week, a homework will be due. So the first homework is due this Sunday, and then Module 2 will be due 2 weeks from this Sunday, and then every 2 weeks after that, there will be an assignment due. And then at the end of the semester, there will be a larger final project. The final project proposal, I might not have posted it yet, but it should be with Module 5. So that will either be forthcoming or is already there. And so there will be a proposal, and then the actual final project, which will be due at the end of the semester. The course is weighted a bit towards the final project. It's worth around, changed the weighting somewhat, but I think I still kept it at around 50%. So definitely sort of keep that in mind as you're working through the class. And I've structured it in such a way that some of the assignments are working towards the final project. So I like to keep the class oriented towards, you're going to have kind of this larger portfolio piece that you'll be working on. And then lastly, the course GitHub link. I had asked everyone in their introductions to post their GitHub accounts, and GitHub is going to be something that I use pretty heavily. So I would prefer it if with projects you guys submit GitHub links. You could have sort of your own CUNY repos. You could have however you want to organize it, but it just really makes it more straightforward for me to get sort of GitHub links and to be able to monitor everyone's repos. And then it's also good for you guys as you continue on professionally. If you're using any of these tools, GitHub is going to be, pretty much what you're using for any sort of collaborative work. So it's definitely something that'll benefit you guys. As I'm going through, we'll start out with just some visualization technique and theory. And if anyone has any questions, feel free to just ask it in the chat. I'll be monitoring that, and I'll sort of address it as questions come in. So yeah, just ask your questions there, and I'll be able to take those. So this picture, does anyone have an idea of what it might be, of what this might be showing? If anyone knows the story behind it, especially as it pertains to data visualization. So first of all, does anyone know what this might be showing? Yep, Gabby saw it in the URL, so that gave it away a bit. This is looking at the Challenger disaster in 1986. This was a disaster that happened out of Cape Canaveral. And unfortunately, in this case, there were astronauts on board. This was an attempted space launch, and it ended up, the shuttle ended up exploding midair before leaving the atmosphere. And what ended up happening was it was a fuel leak from one of the fuselages. So you could see in these pictures, there's a white arrow that's kind of pointing to, a little black cloud that shows, what's happening. And, so these fuselages, they're just entirely filled with fuel. They're meant to just sort of get the rocket, up into space, and are being entirely spent up. And, there's combustion happening at the end of the rockets, and it's not hard to imagine why it wouldn't be a good idea to have a fuel leakage in a situation like that. So that's what ended up sort of causing this disaster, and where particularly the failure was a place called the O-rings. So you could kind of see these O-rings. They're providing structural support for the fuselages, and it was in one of those, sort of structural supports, like that's what failed, and that's what caused the leak to occur. So, and this example, it comes from a book of Edward Tufte's called Visual Explanations, and he and this is an actual copy of the visualization that the engineers were using to analyze some test launches. So these are sort of a series of unmanned test launches. In some of the test launches, there were O-ring failures, and the visualization marks on each of the O-rings where the failure occurred, and then as well, it's showing the temperature of the outside temperature of the trial. So you're seeing all of the information here. You are seeing like where all of the failures are. You are seeing the temperatures of each attempt. But just looking at this visualization, is anyone able to pick out a pattern? Or is anyone really able, does anyone sort of think they might have